In August 2009, a 16-year-old girl flew alone in the cockpit of a single-engine airplane. Its frame was vibrating with the contained energy of its engine. Below her was the solid ground of a Minnesota airfield. Ahead was the open sky. The aircraft, a Zenith Zodiac, was not factory-made. It was a machine made of parts sourced from vendors. Of 15,000 rivets she had set herself. Of an engine she had learned to assemble and disassemble in the foyer outside her bedroom. This was Sabrina Gonzalez Pasterski, and this was her first solo flight in the United States, in an airplane she had herself built. This is the world of Sabrina Gonzalez Pasterski. She is no longer the teenage pilot who stunned federal officials, nor the Massachusetts Institute of Technology, MIT, undergraduate who graduated with a perfect grade point average, though she was both of those things. She is the physicist she became, a theorist, leading a team of researchers in an attempt to answer one of the most demanding questions in science. Her work is called Celestial Holography. By celestial, we literally mean looking up at the night sky, she explains. How do you encode the physical universe as a hologram? The question is audacious. It suggests that our three-dimensional universe with all its depth and substance might be a projection of information stored on a distant, two-dimensional surface at the edge of space-time. To pursue such an idea requires a high degree of rigor and intelligence, qualities she has demonstrated throughout her life. Before she had even completed her doctorate at Harvard University, her work was cited in a paper by Stephen Hawking. She has standing job offers from Jeff Bezos at his aerospace company Blue Origin and from NASA. Forbes magazine named her to its 30 under 30 list not once, but twice, eventually adding her to its roster of all-star alumni. This cascade of recognition cast her as the next Einstein. It is a label she finds uncomfortable, a weight of expectation that she has worked diligently to set aside. In an interview with Time, she was clear. No one will be Einstein. He was who he was. She has spoken of the pressure of the media attention, the feeling of being an imposter because of clickbait. This is the story of a genius who went on to master the physical world and then question its very foundation. Sabrina Gonzalez Pasterski was born in Chicago on June 3, 1993, a first-generation Cuban-American who describes herself as a proud Chicago Public Schools alumna. Her father, Mark Pasterski, an attorney and electrical engineer, created an environment where curiosity was a valuable tool. From an early age, her path was set by a direct, hands-on engagement with the world. She attended the Edison Regional Gifted Center and later the Illinois Mathematics and Science Academy, IMSA, institutions that provided a formal structure for an intellect that was already building its own curriculum. That curriculum was centered on aviation. It began with flight lessons at age 9. At 10, she had moved beyond toys, but was thinking of rebuilding an airplane engine in her home. By 12, she had started assembling a kit aircraft in her father's garage. The project was a physical and financial undertaking, funded in part by the sale of the family's Corvette. Over 2 years, she set nearly all of the aircraft's 15,000 rivets. At 14, with the airplane complete, she sought certification. She went straight to the source, walking into the campus offices of the Massachusetts Institute of Technology, to MIT, to seek approval for her design. It was audacious innocence. An executive secretary at MIT remembered how surprised she was, saying, "I couldn't believe it." Not only because she was so young, but a girl. Yet, when she applied for admission, MIT placed her on the wait list, and Harvard University rejected her application outright. It was the intervention of MIT professors Alan Haggerty and Earl Merman, who had seen the video of her building her plane, that secured her admission. Pasterski entered MIT in 2010 at the age of 17. She completed her undergraduate degree in physics in 3 years, graduating with a 5 GPA, the highest score possible, and became the first woman in 2 decades to finish at the top of MIT's physics program. Her academic achievements clearly indicated her intellectual ability, but a more significant change was occurring internally. Her childhood dream was aerospace. She pursued it through internships at Boeing, Phantom Works, and NASA's Kennedy Space Center. These were opportunities to work at the forefront of the industry that had fascinated her. However, the experience led her to reevaluate. The practical work of engineering, building, and testing spacecraft no longer satisfied her curiosity. The main question had shifted. It was no longer how to build a machine that could fly, but why flight was possible at all according to the fundamental laws of nature. This was a pivot from the world of the maker to the world of the thinker, a move from the certainties of engineering to the deep questions of theoretical physics. Years of pushing the bounds of what she could achieve led her to physics. In 2014, she began her doctoral studies at Harvard, working under the physicist Andrew Strominger at the Center for the Fundamental Laws of Nature. She made an immediate impact. Her first paper was accepted by the Journal of High Energy Physics, a highly reputed journal. Her second was chosen as an editor's suggestion in Physical Review Letters, a distinction for a graduate student. Her early work on a phenomenon called the spin memory effect was so compelling that Strominger granted her academic freedom in the spring of 2015, a rare allowance for a student to pursue their own research directions, a testament to the confidence she had already inspired in one of the field's leading figures. To understand the work of Sabrina Pasterski is to approach the very edge of human knowledge. Her field, theoretical physics, operates in a world built from mathematics, a place where the familiar rules of everyday experience no longer apply. Yet the questions she asks are fundamental. She is part of a multi-generational quest to find a single, coherent description of the universe, a theory of quantum gravity. Modern physics rests on 2 colossal achievements. The first is Albert Einstein's theory of general relativity, which describes the universe on the largest scales. It is the theory of gravity, of planets, stars, and galaxies. It pictures space-time as a dynamic, flexible fabric, warped and curved by the presence of mass and energy. The second is quantum mechanics, the theory of the very small. It governs the bizarre world of atoms and subatomic particles, a world of probabilities and uncertainties where particles can also behave like waves. Both theories work perfectly in their own domains. The problem is that they contradict each other. When physicists try to describe situations where both theories should apply, such as inside a black hole or at the moment of the Big Bang, the mathematics breaks down. The ultimate challenge in contemporary physics lies in discovering a single theory that can unify the 2 existing descriptions of the universe. Pasterski's work offers a new and powerful line of attack on this problem. One of the most dramatic predictions of general relativity is the existence of gravitational waves. Imagine space-time as a vast, stretched trampoline. When a massive object like a bowling ball is placed on it, the trampoline sags. Now, imagine two massive objects, like two black holes, spiraling into each other and colliding. This cataclysmic event would send out ripples across the trampoline. These ripples in the fabric of space-time are gravitational waves. For decades, it was thought that after the ripple passes, the fabric of space-time returns to its original state. But in the 1970s, physicists realized this was not the whole story. The passing wave leaves behind a permanent change, a stretch or a distortion in the positions of objects. This lasting alteration is known as the displacement memory effect. It is as if the wave leaves a permanent scar on space-time. In 2014, Pasterski and her colleagues at Harvard discovered a new type of memory. If the displacement memory is a permanent stretch, the spin memory effect is a permanent twist. It is caused by the angular momentum or spin carried away by the gravitational waves themselves. This discovery, which predates the first direct detection of gravitational waves by LIGO, offers a new way to observe the universe's most extreme events. Her 2015 paper helped to complete a deep and beautiful connection in theoretical physics known as the PSZ Triangle, or the infrared triangle. It is like a Rosetta Stone, showing that three seemingly different languages of physics are in fact describing the same underlying reality. The three languages triangle illustrates three interconnected concepts. It connects asymptotic symmetries, which are space-time symmetries at infinite boundaries, soft theorems describing low-energy particle behavior during high-energy collisions, and memory effects, the lasting impacts of waves on space-time. The PSZ triangle explains that these three concepts are mathematically equivalent. A statement about asymptotic symmetries can be translated into a statement about soft theorems, which can in turn be translated into a statement about memory effects. The young physicist from Chicago quickly gained worldwide recognition. She received numerous awards, including being listed on the Forbes 30 Under 30 for Science in 2015 at age 21, and earning a place as a 30 Under 30 All-Star in 2017. She was also awarded a distinguished Hertz Foundation Fellowship. Job offers soon followed from Jeff Bezos' aerospace firm Blue Origin and NASA. 1. The most significant moment of recognition came in early 2016, when Stephen Hawking cited her 2015 paper on the PSZ Triangle. For a young physicist, a citation from a figure of Hawking's stature was an unbelievable validation. It placed her work firmly in the mainstream of the search for the next great physical theory. This attention, however, came with a heavy burden, the label of the next Einstein. She was aware that the media had sensationalized a captivating story about the girl who built an airplane, the first-generation Cuban-American, the Harvard prodigy, and had created a myth that overshadowed her actual scientific achievements. Her response was not to embrace the myth, but to work harder to justify the attention. She studied doubly hard to earn her physics chops and forestall criticism that she was overhyped. Pasterski's current work is focused on one of the most ambitious ideas in modern physics today, called celestial holography. A hologram, like the one on a credit card, is a flat, two-dimensional surface that contains all the information needed to project a three-dimensional image. Physicists picture this sky as a giant two-dimensional sphere surrounding us at the boundary of the observable universe. They call this the celestial sphere. Celestial holography proposes that our entire four-dimensional universe, 3 dimensions of space plus 1 of time, might be a holographic projection from a simpler two-dimensional theory that exists on that celestial sphere. This is a radical idea. If correct, it would mean that the complex physics of our universe, including the force of gravity, could emerge from a simpler, non-gravitational theory in fewer dimensions. In 2021, she founded the Celestial Holography Initiative at the Perimeter Institute for Theoretical Physics, where she leads a team of researchers exploring this new frontier. Backed by an $8 million grant from the Simons Foundation, this initiative represents a major effort to solve the puzzle of quantum gravity by looking at the universe in an entirely new way. In an age of constant digital connection, Sabrina Pasterski is an anomaly. She has no Facebook, LinkedIn, or Instagram account and does not own a smartphone. Her website, physicsgirl.com, is not a blog filled with personal reflections, but a minimalist professional listing of her papers, talks, and achievements. In an interview, she explained that she would rather stay alert and hopefully be known for what she does and not what she doesn't do. As she puts it, physics itself is exciting enough. It's not like a 9-to-5 thing. After completing postdoctoral work at Princeton, she received an unsolicited offer of an assistant professorship from Brown University, a package worth $1.1 million. She turned it down. Instead, in 2021, she joined the faculty of the Perimeter Institute in Canada, a research center dedicated exclusively to theoretical physics. At Perimeter, she found a culture that matched her own vision for science. In an interview about the institute, she posed the central question: do you fight the competition, or do you work more collaboratively? Talking more can help improve ideas. She sees her role as more than just a researcher. It is about building the enterprise of theoretical physics. As a prominent first-generation Cuban-American woman in a field historically dominated by men, she has become a role model. She has worked with the Let Girls Learn initiative, an effort that earned her an invitation to the White House. She embraces her heritage, but insists on being judged by her work. In a 2017 interview, she stated, "Personally, as a woman, I feel no disadvantage, and that her mentors do not treat her differently because she is female." She finds it empowering to not feel different, in the sense that any criticism I get isn't because I'm a girl, it's because I can be better. In an interview at the Miss Global Forum, she offered a glimpse into her motivation. To be critical about yourself is fine, but to be hopeful about what you can do when you put the effort in is something I see as something that guides me. The future ahead for Sabrina Pasterski remains as open as the sky she flew through as a teenager. Her work on celestial holography is a long-term project, a search for a new language to describe reality. She is comfortable with the uncertainty. The fun thing about physics is that you don't know exactly what you're going to do, she said in an interview with Discovery Canada, and normally things just change very quickly. The story of the girl who built an airplane is complete. The story of the physicist who is attempting to decode the universe has just begun.